Good day to you, students. I hope you guys are doing fine in your various homes. In our last class, we discussed water, where we spoke extensively on hardness of water. Today, we are going to look at the second type of hardness, which is titled permanent hardness of water. To start with, what do we mean by permanent hardness of water? Don't forget, in our last class we said temporary hardness is a type of hardness that can be removed by boiling. But in this case, you don't remove these by boiling, but instead of doing that, you make use of chemicals like caustic soda, washing soda, and ion exchange resin. Now let's quickly look at what is actually responsible for permanent hardness of water. This type of hardness is caused by the presence of calcium ion or magnesium ion in the form of tetraoxosulfate. What I'm trying to say is that anytime you have permanent hardness in water, that means such water is having calcium sulfate or magnesium sulfate. So from here, can you see we have calcium ion and magnesium ion here? Unlike in temporary hardness, where what is responsible for temporary hardness are calcium hydrogen carbonate or magnesium hydrogen carbonate. All right. Now, water acquires permanent hardness whenever it dissolves gypsum. What do you mean by gypsum? The chemical formula of gypsum is hydrated calcium sulfate. That is calcium tetrasulfate 6 dihydrate. This is what you call gypsum. All right. Let's quickly move to how we can remove permanent hardness from water. The first method is by adding washing soda. Addition of washing soda. The chemical formula of washing soda is sodium triisocarbonate 5. Now let's look at the chemical equation to represent this. This is calcium sulfate. That is your permanent hardness. Then you react it with washing soda. Then to give us calcium carbonate plus sodium sulfate. So this calcium carbonate is said to be insoluble in water, which can easily be separated from the water. And that is exactly what is causing the hardness in water. And the same thing is also applicable when you have magnesium sulfate. You react it with washing soda to give you magnesium carbonate plus sodium sulfate. Magnesium carbonate is also said to be insoluble in water, and it can be separated by filtration. Then let's look at the second method, by addition of caustic soda. Caustic soda means sodium hydroxide. When you react sodium hydroxide with permanent hardness, that is calcium sulfate, it will give you calcium hydroxide plus sodium sulfate. This calcium hydroxide is what is actually responsible for the hardness in that water, and that is what you have removed here. It's an insoluble compound, which can also be separated by processes like filtration and other separation techniques. Okay, let's look at the third one, by using ion exchange resin. In this case, there are two resins you make use of here, and these are zeolite or perlmutate. Zeolite is also the same thing as sodium aluminum tetraoxosilicate, and this can also be referred to as sodium zeolite. So during this process, there is always an exchange of ion. Don't forget, calcium is what is responsible for hardness. So the calcium you have in this calcium sulfate will be replaced by sodium in sodium zeolite, while sodium will replace calcium. Then when you look at what we have here, it now becomes sodium sulfate plus calcium zeolite. The same thing is also applicable for magnesium sulfate. The magnesium will come here to replace sodium, and sodium will also replace magnesium. Then to form sodium sulfate plus magnesium zeolite. Now, the most important thing here is that this is a continuous process. The calcium zeolite that is obtained here cannot be reused until it changes back to sodium zeolite. And how can you change this calcium zeolite to sodium zeolite? Is by passing the calcium zeolite over a concentrated solution of sodium chloride, and that is your brine. That is, when the zeolite is used up, it can be regenerated by passing the calcium or magnesium zeolite over a concentrated solution of sodium chloride to yield sodium zeolite again, which can be reused continuously. Now, what are the advantages of hard water? Number one, it tastes better than soft water. And why does it taste better than soft water? It is because of the presence of mineral salt in it. Then the second one, it helps in the building of strong bones and teeth. That's why you see at times we have some drugs that will be recommended for whoever that is having dental problem. They will ask them to use calcium-rich food or to take calcium-rich drugs. It's because hard water is having calcium in it. Then we also have, it helps animals like snails, that is the crustaceans, to build their shells. Animals like snails, like crabs, and so on and so forth. Then the next one is, it does not dissolve lead. And for that reason, it will never cause lead poison. So whenever hard water passes through a pipe that is made up of lead, such water cannot dissolve the lead content of that pipe. So for that reason, it will never cause lead poison. Then what are the disadvantages of hard water? Number one, since hard water does not lather easily with soap, that means it will keep wasting our soap. That is the first disadvantages. Then the second one is it causes fouling of kettles and boilers. Don't forget we have spoken about fouling of kettles and temporary hardness of water. Then the third one, it causes stalagmite and stalactite. We have also explained what stalagmite and stalactite is in our previous class. Then lastly, it is not applicable in dyeing industry. When you see all this dyeing industry, they don't make use of hard water, but instead they make use of soft water. With this little explanation I've made, I believe I've been able to teach you students one or two things today. But this is just a few things among the many more things we are still going to discuss at the Google Classroom. As you watch this, and I expect you at the Google Classroom, I pray you remain blessed. Thank you.